Hello everyone and welcome to another 3DOptix live webinar. My name is Keith Myers and I am an optical designer working with 3DOptix. Today I will be introducing you to importing CAD objects in 3DOptix for both optomechanical and optical components. This is a really great tool as we can quickly prototype systems using CAD files from a manufacturer or ones we've created ourselves. The process to insert these objects is simple and easy, making an ideal tool to utilize during the design process. Okay, so with that said, I hope you enjoyed the webinar. Now let's go ahead and open up the project and start. Okay, and this brings us to our 3D viewer here. Okay, so 3DOptix has a readily available stock CAD catalog here on the left on the outliner bar. From here, we can look through the selection that 3DOptix provides and also of our own private catalogs of parts that we've imported into the cloud using the CAD import tool. Note that once we import a CAD file, whether a mechanical mount or an optic, that it will be saved to our private catalog so we can use it across any of our designs. Again, you can find it here in the drop-down private catalog, as well as the 3DOptix catalogs. Okay, and as you can see, I have a few mounts and optics that I've imported from other previous designs here. Okay, so now that we know where to find the CAD catalog and where our imported objects go, let's go ahead and import a few objects into the 3D layout. Let's drag and drop one of the CAD objects from my private catalog. So we'll do the tower here. I downloaded this from Thor Labs. And notice that 3DOptix automatically places it above the breadboard. So let's go ahead and click on the tower and look at the positioning and the coordinate system. Okay, so it looks like the coordinate system for this CAD object is in about the center of it. Okay, and it's also, as I stated, floating above the breadboard a bit. So let's go over to the ribbon bar here and let's set it to the origin. And when we do this, the local coordinate system will be co-aligned with the global coordinate system. Set that to 0, 0, and 0. Okay, perfect. And now we can see it is straddling the breadboard. So let's go down here to the coordinates cube and click on the -z so we get this nice slice view. We'll click on the tower again and we'll move this up a bit so it looks like it's resting on the breadboard. All right, let's go up a little bit higher. Okay, a little bit lower. Perfect. Okay, so that looks like it's about resting on the breadboard where we would want it to be. All right, so a lot of times with the CAD objects, you'll have to maneuver them around depending on where the coordinate system is and also the dimensions of the object. Okay, so let's go over one more imported CAD object I have just to see how we use larger CAD objects. So go back to my private catalog here and we'll pull in this light box. And then we'll just move the tower out of the way a bit, maybe up here in the corner. Okay, great. So let's go ahead and click on this light box. All right, now one thing to notice is instead of being in the center of the CAD object, the local coordinate system here is on the bottom of the CAD object. So if we set this back to the origin, this will more look like it's sitting on the breadboard. Okay, perfect. So let's go back to the coordinate cube, click on this really quick. All right, looks like it needs to go down just a little bit more. So let's go ahead and do that. Perfect. All right, and now it looks like it's sitting on the breadboard. Great. Okay, so let's move on. One note on CAD objects is we have the 3DOptix catalog, and we also have our private catalog where we can import CAD objects. Now, if there is a mount or another CAD object that is in the 3DOptix catalog, it's always better to take it from the catalog because the catalog optics have some native additional options such as post and post holders for height positioning, and also the ability to place an optic inside of optical mounts. So let's go ahead and move this light box over here. And what we're going to do is we're going to search for a KS4 mount from Thor Labs. And this is in the 3DOptix catalog. All right, great. There it is. Let's pull this in. All right. And let's take a look at this CAD object. Okay. So as you can see, the CAD object, because it's native, is sitting on the breadboard already, and it has a post holder here. So let's go up to the ribbon bar, kind of look at some of the additional options. So one of the options is post settings. So instead of moving the Y height up and down, we can just simply move the post up and down instead. And we can also move it down. So we've got a little bit of a range of motion here for the CAD object. Now, in addition to that, let's click on that and go back up to the ribbon bar. If we go to Optics settings, and we can click this search optics icon, and this will actually bring up the optics catalog, and we can search for optics that will fit inside this mount. So when we do this, it automatically places filters so we can see which optics can fit in the mount. So let's go ahead and just pick the first optic in the list. And we'll go ahead and add this to design. Okay, and as you can see, this automatically puts the lens in the mount perfectly. So we don't have to position anything, and we don't have to, through trial and error, position it in the mount. Okay, let's get a top view here. So let's click on the mirror that we just put in, and we'll click on the move rotate. And from here, you can see that it's now referenced to the kinematic mirror mount. And if we move this back and forth, we can reposition the optic inside the mount. Okay, so again, if the CAD object is already a 3DOptix object, and we have more options than the ones that we import ourselves. So we would always want to use the CAD objects that 3DOptix already has natively. However, the included 3DOptix tool to import CAD objects is extremely helpful for custom designs and objects that are not currently in the catalog. Okay, so we're done with the catalog that is available in 3DOptix. Now let's go ahead and learn how to import CAD objects into our private catalog for use in optical systems. So we'll go back and we will move this mount with the mirror inside of out of the way. Now there are two ways that we can upload CAD objects into 3DOptix. The easiest way is to right-click in the 3D layout and go down here to the Import CAD option. The second way is to go up to the File tab and then down to Import CAD again. Now this will tell you that you can only upload files up to 30 megabytes, and also as a percentage how much storage you have left. So I import a lot of CAD objects, so I've used up quite a bit of my storage. Okay, so let's go here to the breadboard and just right click and do it this way. So from here, the Import CAD Object tool will bring up this window, and the first thing you want to do is select what type of object you want to import, either optomechanics or optics. Now, they do have different options, so if you're importing an optic, you'll definitely want to click the Optics tab. But for this first CAD object, let's go ahead and upload an optomechanics. So we will browse for the file, and we're going to import this Thorlabs pinhole. We'll rename this. So this is a 1mm by 1mm Thorlabs pinhole, so it's square. Now we can also use a custom color here. So the standard color is black, but we can change that if we so choose. We'll just keep it as black for now. Okay, so we'll go ahead and import the object. So this will take a little bit of time, but this is a lower resolution optic and or CAD object, and it's very simple, so it won't take very long. Obviously, if you have really large files up to 30 megabytes, it will take a bit more time. So once this uploads, we'll check the CAD object and the pinhole dimensions just to make sure that it did import correctly, because we want to make sure that there was no errors in the process. Sometimes some faces do get skewed just from the import process. We want to make sure that none of that has happened for this object. Perfect. Okay, so as you can see, once you upload it, it will place it in the center of the breadboard. Let's go ahead and click on the pinhole. Move a little bit closer to it. Okay, great. And now that the pinhole is loaded, let's go ahead and do some measurements and make sure that everything was imported correctly. So the first thing we're going to do is check the pinhole dimensions. So what we're going to do is go up here to the taskbar, and we're going to use the measure tool. And then we're going to go in here, And we're going to choose two edges to take a measurement of the pinhole size. Perfect, 1 millimeter, just like we expected. Let's go over here and reset the measurement tool so we can get rid of that measurement. Now, any surface or any edge that has this orange dot is able to be measured. So we can even measure the diagonal if we want. There we go, about 1.41, that makes sense. Go ahead and clear this. Now we can also measure radii. So this lip isn't important, but we can still measure it. So the radii of the lip is about 3.6 millimeters. Okay, great, perfect. So the measurement tool is good to use to make sure that CAD objects have been imported correctly. You can check a few dimensions really quickly and make sure there was no errors. All right, so adding mechanical CAD objects is pretty straightforward, and we don't have to worry too much about the import process other than checking dimensions. With optical CAD objects, we definitely want to make sure that the import process worked and that the object has the correct optical properties. So let's go ahead and move the pinhole to the side. And let's pull up the import menu again by right-clicking, and this time in the Import CAD Object tool, we're going to select Optics. And for this, I have a Thorlabs LA1131 lens that we will import. And for this example, we're going to use a low resolution model because medium and high will take a little bit longer, and we don't want to wait too long to import this. We'll name this Thorlabs Low Res Lens. Okay. And again, we can use the 3DOptix color or just the standard black. Okay. We're going to go ahead and click Import here. Now it is going to ask for a material. That's one of the differences between optics and optomechanics. So the material of this lens is NBK7. So we'll go ahead and find that. Perfect. All right. And now we'll upload this lens. So depending on the fidelity of your simulation and what the purpose of the optic is, you can use low, medium, and high resolution. And we'll take a look and see how accurate the low resolution import of the CAD object is for this lens. And we can do that by looking at the focal length. And the focal length of this lens is roughly 50 millimeters nominally. Okay, great. So the lens is now in. And if we go over to the outliner bar and click on parts, you can see we have our Thorlabs low res lens. Perfect. Okay. All right. So one item to notice when we imported this lens is the local coordinate system. The local coordinate system is actually located inside the lens. Now, if we're just positioning this lens somewhere in the optical system, it may not be a big deal, but this will make it harder to position it precisely. So what we're going to do is we're going to right-click, and we're going to add a coordinate system. We'll go ahead and add a coordinate system to the back here. So we're going to select a side, and then we're going to select the center of the lens. We'll move to the y-axis. There we go. And once we select the y-axis, the z-axis automatically pops up. Okay, great. So because this is a better reference surface, we're going to change this, and we're going to set this as a local coordinate system. We're going to name this back, just so we know where it is. Perfect. Okay, so that looks pretty good. Now we do want to measure this to a baseline, and the LA1131 is actually in the 3DOptix catalog. So let's go ahead and pull in that lens. So we'll open the product catalog here, and we'll look for the LA1131. Now, the lenses in the catalog have been imported using their lens prescription, so they will be idealized lenses. So there will be no CAD import errors, and that's what we want to check. Okay, so let's go ahead and turn this lens around and position it at the origin. There we go. And we're going to rename this stock lens. Perfect. Okay. Now we'll grab the low res lens. We'll just move it slightly below. And then down 20. we go. All right, reorientate that. Okay, and we'll pin this. Okay, there we go. This one's off a little bit. We'll move him back up. There we go. And one thing I do want to change, because the local coordinate system of the lens that we've imported, the low-res lens is now the back, we want to change the stock lens's local coordinate system to the back as well for easier positioning. So we're going to go ahead and right-click on this and set this as local coordinate system. And again, this will make it easier for alignment. So we can get everything in the same plane. Okay, and then we'll choose the other lens and we'll have this go down a little bit more. Perfect. And so we can see that we're more co-aligned here. Okay, so the next thing we want to do is right-click and add a light source. There we go. Now for the light source, we're going to reference it to each lens. And since it'll be a collimated source, we can get it relatively in the same place. We don't really care exactly where it's placed as long as it's co-aligned with the optical axis of the lens. Go into light source settings. You use a plane wave because we want to simulate a laser. We'll keep the 3D layout and analysis rays the same, or the default value. For spatial information, we'll keep it a circular beam with a radius of 5 millimeters. Angular information, we do want this directly incident with the lens, so we'll leave this alone. Wavelength information, we're going to edit this and we're going to choose 633 nanometers. Go ahead and apply. And for the power and polarization, we'll just keep this the default options. All right, so now let's duplicate this and do the same referencing for the other lens. Okay. Move that back to 50, this to 0. Maybe move this guy a little bit more. Perfect. Okay. All right, now I already have imported a medium resolution and high resolution lens into my private catalog. So we're going to go ahead and grab those so we can see the difference between all the import options, low, medium, high, and stock optics. Let's go down here. So we have the medium resolution lens here and the high resolution lens here. So let's go ahead. Let's go medium resolution lens. This will make it easier to move things around. We'll pin this and then high resolution lens. Okay, perfect. And now again, we're going to have to add coordinate systems to both of these because the coordinate system is in the body of the lens. We'll right click. We'll select this back edge and the center. And then we'll go to the y-axis. Okay, perfect. And we'll again set this as the local coordinate system and name it the back. And finally, for the last lens, we're going to do the same thing. And we'll select the center and the y-axis. And once the y-axis populates, the z-axis populates. Okay, so now everything is relatively the same. We have all the local coordinate systems to be the back, so it's a little bit easier to reference all of these. So we've got medium resolution, high resolution, name this low resolution just to keep the naming convention the same. All right, and then we'll move all of these. There we go. Do the same for the high resolution lens. Okay, perfect. Now we have all the lenses. Actually, I want to get this down a little bit more so they're not touching. One more, perfect. And lastly, the high resolution lens. There we go. So there's a little separation between them all. All right, let's go ahead and duplicate this light source twice. There we go. And then we'll reference the light source to each of their lenses. It's going to be 0. Oh, maybe -50. There we go. And 0. All right, and last, the high resolution lens light source. Go, -55 and 0. Okay, perfect. Now we have all of our light sources and all of the lenses. Go ahead and propagate the simulation just to make sure I'm aiming the light sources in the correct position. Perfect. Okay, unfortunately, I am facing the opposite direction. So let's go ahead and flip these around. We'll pin this. So 90 on here. Then 90 on here. Okay. All right, so that should work now. And once this finishes the ray trace, perfect. Okay, everything looks good. Last thing we're going to do with the light sources, I do want to change the color. So I'm going to go up here to Appearance. So this one will be red. Okay. This one, and we'll pin the light source settings so we can quickly iterate through these. That's green. That one's red. That one will be blue. And the last one will be yellow. There we go. Perfect. And then we're going to go up here to the View tab, and we're going to change the ray color palette to user defined colors. There we go. Now we have a nice different color for each laser, except the first and the second. Let's maybe change that to a different color of yellow. There we go. Okay, now they're all different colors. Perfect. All right, the last thing we need to do is add a detector, because what we're going to do is we're going to analyze the focal position for all these lenses based off of the stock optics back focal length. So let's go ahead and right click and add a detector. We're going to change this detector size to 1 by 1 because we're going to be measuring the focus, so it will be small. There we go. And we'll reference the back of the lens. So this is the stock lens. Let's go ahead and reference the back of it, and that will make it easier for positioning so we can get it exactly aligned to where the focal length is. Okay, so the first thing we're going to do is we're going to go and look at the optic setting for the stock lens. So this is our stock lens, the one that was imported from the 3DOptix catalog with the lens prescription. We're going to click on Optic Settings, go into Optical Settings, and we're going to look at the geometrical properties. All right, so we've got effective focal length here, back focal length, and front focal length. So we're really quick going to change the wavelength here so we get the correct back focal length, because that's the one we want. That will be from the planar surface. So that looks to be, well, let's get the wavelength correct. There we go. So it looks to be about 46.6 millimeters from the back of the lens. Okay, excellent. So let's position all of our detectors at the same distance away. So minus 46.6, perfect. I'm going to duplicate this. Okay, click on that lens, reference it to the low resolution lens. There we go. Move it down. Minus 46.6. How about there? Okay. All right, so that is again just a duplicate, so it's a 1 by 1 half width. Let's again duplicate this one and do the same thing for the medium resolution lens. Okay, we'll reference the local coordinate system, which is the back of the lens. 46.6 and 0. There we go. Okay, and the last one. Duplicate the detector, reference it to the back of the lens for the high resolution lens. 46.6 and 0. Perfect. Okay, so we now have a optical system where we have a lens being illuminated by collimated light, And we have the detector at the focal length, the ideal focal length of the stock lens. And now we can analyze how big the focus is at that position for all the lens that we've imported. Okay, so now let's go to the analysis window at the top of the taskbar here and look at the output. So we'll go over here to Analysis Portal, click on that. We're going to change this to spot go in here at Advanced so we get a few more rays in the simulation. And we'll keep the pixels at 100 by 100. Okay, actually the one last thing I wanted to do was rename the detectors. And I want to do this so it's easier. So this will be stock detector. So it's easier to figure out which detector is which when we're doing the analysis. So we'll pin this. And then this is the low res lens. So this will be the low res detector. This is the medium res lens. So this will be the medium res detector. Okay, and last is the high resolution lens. So this will be the high resolution detector. Perfect. Okay, so now that we've renamed these, we can easily see which is which. Let's go back to changing the analysis type. Okay. All right, so that should be good. All right, what we're going to do is run the analysis, and then we're going to compare all the detectors and see which one looks best. Obviously, the stock optic should be the best because it's using the lens prescription, but we'll see how it compares to the imported CAD lenses. Okay, down here in notifications, we have one more analysis, and now we're complete. Perfect. Great. Okay, so let's look at this. There is nothing in the screen, so this tells me that my detectors are not facing the correct way. So let's go ahead and turn off the light source. A really great feature of 3DOptix detectors is they tell you if they're facing the right way or not. So if we look at here, the detector is telling me that this is the back, so it's not going to measure anything because it's expecting the light to come from the front. So let's go ahead and make this 90 degrees. Okay, great. Now the front is facing. It's going to be the same thing with this lens. Now it's the front. So again, this is a really great feature of the detectors. If you're wondering why you're not getting anything on the detector, just make sure that the front of the detector is actually facing the light source. 180, perfect, there we go. Okay, and now when we go back into the analysis, we will run this again and we will be able to get the spot sizes there. Okay, great. And we can just track in the notifications windows down here when our analysis is becoming complete. Perfect. 404 analysis complete. Should be popping up. All right, and now we actually have a spot on the detector. So we're going to hit compare on all of these detectors so we can pull these up in one window. There we go, and we'll hit compare selected. Get rid of that. All right, perfect. So you can already see that the low resolution lens has some issues with the way it was imported, so it doesn't faithfully recreate the actual lens. Now, the medium and the high resolution look very similar to the stock lens. So let's go ahead and look at the low res lens and look at our baseline lens here. So this is the stock lens on the left and then the low res lens on the right. And we can obviously see that there's some issues with the import here. Not bad, but it is still generating some aberrations where the catalog lens is not. All right, so let's look at the other ones. We'll bring up the medium and the high here. Okay, position this guy over here. All right, and then we can look at the medium and the high res really quick, all at once. There we go. Okay, so that looks a lot better. The medium and high don't focus the light as well, but the spot size is relatively the same and very circular, just like the stock catalog lens. So that's great. So we can see that the medium and high are slightly better. The low res doesn't quite give us as good a fidelity as the other ones, but depending on your simulation situation, it may be good enough for that. Okay, let's go ahead and close these out. All right. Now, some optical CAD objects, such as prisms or other more linear components, this won't matter as much. A low-res model of a flat plane will most likely be very similar to a high-res model of a flat plane, say if you have a prism or a beam splitter square or other linear components like that. But for lenses or other curved optics, it's probably better to use a higher resolution or at least test the lower resolution lens if you're going to include a low resolution lens in your system. Okay, great. Now that we have imported a few CAD objects, both mechanical and optical, one useful tool in the 3DOptix catalog is to group objects together so they move as one. So let's go ahead and move up to the top taskbar and click on the group button here, or the group tool. Let's click on that, and this is going to bring up the group tool. Now, this is going to direct us to click on parts to add to the group. What we're going to do is click on the detectors, or the light sources, and the lenses. Now, the detectors are referenced to the light sources. They're a little bit small, so they'll just follow the detector or the lenses around. I could click on each one of these and include this in the group, but again, since they're referenced the lens, they'll still move around with them. And the next thing I'm going to do is include the light box. Okay, and we're going to name this light box group. Perfect. Okay. Now, when you have a group and you click on one of the components, you'll actually be able to move all the components at once. Go ahead and turn off that light source there. Now, if you want to move just the component, one of the components in the group, then you just need to click on it and then you can move it around independently. So click on it in the outliner bar and then move it independently around. Okay, so again, generally with a light box, we're going to want that over our optics. And again, we want this to be, let's go ahead and click on that. We want this to be transparent so we can see what's in the light box. So we're going to go to CAD optics settings and hide those surfaces again. There we go. And now we can see what's in the light box. Okay, great. So let's move this to the side now. Perfect. So if we go to the outliner bar and select the light box, we can make it transparent. It does become opaque every time we move it, so we would need to go in here and make it transparent again every time we moved the light box group. Okay, so let's move on to another CAD object here. I've imported a dove prism for this example, so we'll go into my private catalog. So we'll go to the outliner bar, go into the catalog, and we're going to drag in the dove prism into the 3D layout. We'll zoom in here, and we're going to click on the prism, and I want to turn it on its side. So we're going to go over here and move it or angle it 90 degrees. Perfect. And I do want to hide surfaces. I want to see through it. So that gives us a nice view of the prism. All right, great. Now let's add a light source so we can have it propagate through really quick and do a couple neat options with the surfaces of the prism. Go ahead and propagate simulation. All right, perfect. Now the light source is coming through, refracting, and then transmitting through. Okay, great. So that's what we would expect. Now let's apply some coatings to the prism and see what options are available. We can right-click on any CAD object's face and interact with each one individually to apply coatings or scatterings, or we can use the ribbon bar to do the same thing. So as you can see, we can right-click on the right leg here and go down to change the settings of this object. Now let's go ahead and go to CAD object settings so we can see all the faces at once. Okay, so the optical surfaces are listed down here. And as you can see, I've already renamed them just to make it a little bit easier. If we look at the 3D layout here, we can see that as I scroll through each face, it will highlight the face that I'm scrolling over. Okay, so first let's go to the left leg and change the coding type. So you can see here, we can change the face to be a total absorber, ideal reflector, or another one of the options in the drop down. Let's make this an ideal reflector. Perfect, and we'll save this. All right, let's go ahead and again make this hide the surfaces so it's opaque. Let's go ahead and propagate the simulation. And what we should see here is a reflection off. Perfect. Okay, great. As we can see, now that it is reflecting, it will reflect it through the prism. So we've modified just a single face here. Now we're going to click on this again and go back into the CAD Optix settings. And we're going to change that left leg now to be a total absorber. Let's make sure that that works. Again, we'll propagate the simulation. Excellent. Okay, and now the left leg is a